Hello, Math Humans. We're going to do 4.3b today. We're going to be talking about some right triangle applications. Our objectives are that we're going to use right triangle trig to find measurements that are difficult. Those are often called indirect measurement. And then these types of problems are AKA word problems. There's a couple of key things that we need to talk about before we get started. Number one is the vocabulary. So if you're a human and you're looking straight across, this is called the line of sight. It is also called the horizon line. Okay? And so let's say here's the tree. This is also called a horizon line. So it's important to notice that the horizon lines are parallel. Because those lines are parallel, if they're cut by a transversal T, then it means that those two angles, which are alternate interior angles, yay geometry, are congruent, equal, because they are on opposite sides of the transversal that cuts the two parallel lines. Another thing that's important to notice is the angle of depression is from the horizon line down, and the angle of elevation is from the horizon line up. We do not do math usually on that angle. We like to move, if they're giving you the angle of depression, we like to go ahead and move it down here because it's similar to a reference angle, and then that means that our math is a little bit easier. So as we get started, we're just going to do a couple of problems and we're going to set them up, and then we're going to move into our word problems. So for example number one, it says solve for x. Well, this is pretty easy, so I get to decide which ratio I want to use, sine, cosine, or tangent, just simple right triangle trig. Because I don't know the hypotenuse, I'm going to use tangent, so I would say the tangent of 27 is opposite over the adjacent, and then I cross multiply, and I'm going to get x is equal to 14 divided by the tangent of 27. Notice that my units are degrees. Oftentimes in these types of problems, our angles are in degrees. So you want to make sure you change the mode in your calculator. And when you push buttons on your grapher, you're going to get that x is 27.477. And then it would be some unit of measure if it were given. And so then I would report 27.477. So that was pretty easy, except you can't see it. Alrighty, if we look at example number 2, same kind of directions, find x. Well, in this one, I'm looking for the hypotenuse. I know an opposite, so I'm going to do sine. So I would say the sine of 48 is opposite over the hypotenuse, x. And again, I cross multiply, so I'm skipping a step. So I'm skipping showing that I cross multiplied, and I'm going straight to the division. If you can't do that without making mistakes, then don't skip steps. Alrighty, and then if I push buttons in my handy dandy calculator, I get 29.604, and then I report well. If there had been units, let's say that had been miles, then that means that when I find my x, then I would also have to report the units. So you need to be very careful with that. So the next example that we're going to do is example number 3, and I have them pre-written just so we can save a little bit of time. And in this one, we have a biologist who wants to know the width of a river so that instruments for studying the pollutants in the water can be set properly. From point A, the biologist walks downstream 100 feet and sights point C. Okay, and then from this sighting, it is determined that theta is equal to 54 degrees. Okay, so how wide is the river? So basically, we're going to draw our little situation. So here's my river. It's lovely, don't you think? And so I'm going to start here. This is my distance across the river, so I'm going to call it W for width. This is A. I'm going to walk 100 feet downstream, assuming that's down, to point C, okay? And I'm going to, point C's up here, my bad. So I'm going to call that guy B. And it says that my theta is 54 degrees because I look from this point to C. He is 100 feet, and I want to find the width of the river. Again, we assume that this is a right triangle because otherwise the math gets a little bit entertaining. And so if we notice we don't have the hypotenuse, so again, we're going to use tangent. So I would say the tangent of 54 is opposite over the adjacent. So W is going to equal 100 because I'm cross multiplying tangent of 54. The units are degrees. You need to make sure that the mode of your calculator is correct. And then I'm going to get 137.638 feet, okay? And then I would report well. So this is 137.638 feet, and that would be the width of the river. So these types of problems are really pretty straightforward, and then they get a little bit more fun. So let's talk about example number 4, because example number 4 is a little bit more fun. So while hiking on a level path toward Colorado's Front Range, Otis Evans determines that the angle of elevation to the top of Long's Peak is 30 degrees. Moving 1,000 feet closer to the mountain, Otis determines that the angle of elevation is now to be 35 degrees. The closer you get to something, the steeper the angle of elevation. How much higher is the top of Long's Peak than Otis's elevation? Basically, they're asking you how tall is Long's Peak. So if I start by drawing a picture, which is what you should always do, so Otis is going to be right here. We'll call, I hate O's, I'm just going to write Otis. Otis is right there, and he's looking at the top of the peak, and it's 30 degrees, so I'm going to call this our peak. And then he moves 1,000 feet closer, and the next angle of elevation is 35 feet. So I'm going to label this H, and I'm going to label this X. Okay? So in these types of problems, there's a couple of different ways you can do it, and I'm going to show you 2 different ways. I tend to do tangent first, but that doesn't mean that cotangent, and that's actually going to be our second example, isn't appropriate, but we're going to start by doing the outside triangle and the inside triangle. So if I start with the outside triangle, I would say the tangent of 30, okay, is going to be opposite H over the adjacent, which is 1,000 plus X. And at this point, I'm just going to stop there. And then I'm going to write my tangent for the other triangle. The tangent of 35 degrees is H over X. So we're actually trying to solve for H. So I am going to set both of my equations, and I'm going to solve for H. Okay? So in the first equation, I get H is equal to the tangent of 30 times 1,000 plus X. And then I'm going to distribute, so H is equal to 1,000 tangent 30 plus X tangent 30, okay? And then I'm going to solve for H in this equation, and I'm going to get H is equal to X tangent 35. So just like problems that we've done in other chapters, the H's are congruent. They are equal because the height of the mountain is the height of the mountain. So I'm going to set these 2 equations equal. So I'm going to get 1,000 tangent 30 plus X tangent 30 is equal to X tangent 35. And because ultimately I need to solve for X, I'm going to move this to the other side. So I get 1,000 tangent 30 is equal to X tangent 35 minus X tangent 30. So on the right-hand side, because I need to solve for X, because once I find X, I can find H, I'm going to factor out an X, and so I'm going to get X times the tangent of 35 minus the tangent of 30, okay? The goal at this point is to solve for X, so I'm going to write that X is equal to the 1,000 tangent 30 divided by the tangent of 35 minus the tangent of 30. And when I do that in my calculator, now you do need to be very careful with parentheses, but you also need to be careful with the mode. So your grapher should be in degrees. And remember, this opens a parentheses, so you need to close it. and then the entire denominator should be in parentheses as well. When you do that math in your grapher, you get that x is 4699.358. But the problem said, what's h? So now I can find h by substituting the x value back into one of my two equations. This one's easier, so I'm going to use that one. So h is going to be x, the 4699.358, and I'm going to multiply by the tangent of 35. And when I do, I get that h is 3290.526 feet. And then I would report h is equal to 3290.526 feet. And then we're done. So it's really not a complicated process, but you do have to be very careful with your math. Just like when we were doing compound interest problems or logarithms, I recommend that you not push buttons on your calculator until you get to a point where it's going to make sense to do that. If you push buttons on your calculator all along the way, you will create a lot of error, and then you will actually get the problem wrong. Okay? I have one more example for us. So it's the same basic type of problem, but we're going to approach it a slightly different way. So when traveling across flat land, you notice a mountain directly in front of you. Its angle of elevation to the peak is 3.5 degrees. After you drive 14 miles closer to the mountain, the angle of elevation is 9 degrees. Remember, the closer you get to an object, the steeper the angle gets. Approximate the height of the angle. Okay? All right, and I lied. I thought this was my one for cotangent. We can set it up that way and do it that way. Cotangent's not my preference. Actually, I think I'm just going to set it up and do it with tangent because that just makes my brain happy. So it's the same basic situation. So I have a triangle and I have a mountain. So H is going to be my mountain. And then I'm going to start over here, and I have 3.5 degrees. I drive 14 miles closer, and I get 9 degrees, and I'm going to call that distance x because I don't know that distance, okay? The goal is to ultimately solve for h, so I think I'm just going to do it the same way that we did the last one because I think that's a little bit more straightforward. So I'm going to start by the big triangle on the outside. And so I'm going to say the tangent of 3.5 degrees is equal to the opposite over x plus 14. And then my other triangle is going to be the tangent of 9 degrees is h over x. I'm going to solve both equations for h. So h in the first equation is the tangent of 3.5 times x plus 14. I'm going to finish this piece first. So h is x tangent 3.5 plus 14 tangent 3.5. And in this equation, h is going to equal x tangent 9. Now I'm going to set my two h's equal to each other. So I'm going to get x tangent 3.5 plus 14 tangent 3.5 is equal to x tangent 9. Again, I need to have all of my x's on the same side of the equation, so I'm going to subtract this guy, move this guy. So I get x tangent 3.5 minus x tangent 9 is equal to a negative 14 tangent 3.5. Not to panic. Because I have this in this order, the negatives are going to work themselves out, so don't panic. Factor out my x, and I get the tangent of 3.5 minus the tangent of 9, and then I have a negative 14 tangent 3.5. I'm going to solve for x, so x is going to equal a negative 14 tangent. Uh-oh, hang on just a second. My little thingy went away. Come back. There it is. Negative 14 tangent 3.5 I'm going to divide it by the tangent of 3.5 minus the tangent of 9. And when I do that math, you get that your x is equal to 8.807 miles. But remember, the goal is to solve for h, so I'm going to substitute it back into an equation. So I'm going to get h is equal to x tangent 9, so it's going to be 8.807 tangent 9, and so I'm going to get h is equal to 1.395 miles, okay? And then what were we looking for? We were looking for the height of the mountain, and then this would be my solution, politely identified. Couple of things to talk about when you're doing these types of problems. Number one, you always need to draw the diagram. You need to set up your ratios, and then you need to be very careful. And I would not push buttons until I got to a point where that makes sense. You need to be careful with your signs because the signs tend to work themselves out, but you have to make sure that you're being very careful and diligent with your signs. You could also set this problem up with cotangent, and let me just show you that up here. I'll just talk about it a little bit. The cotangent of theta is x over y, so I could have said the cotangent of 3.5 is equal to the 14 plus x over my h. So I can solve the problem doing either tangent or cotangent. Some people are particular to cotangent. Because of all of my drafting, my default is typically tangent, so I would take this approach, but sometimes this is much more direct. All right, that is it for today. I will see you soon.